Hey guys, what's going on? It's Mr. Dorado here with the new chapter on our algebra unit. Okay, so we're actually taking a quick look at the chapter 5 unit, all right, which is on systems of linear equations. Okay, so for 5.1, that's exactly what we're going to take a look at. So we're going to try to solve system of two linear equations by graphing. Now, again, this is similar to what we've been doing before because we're still using a lot of the same concepts, but we are throwing a little bit more information in here for chapter 5. So we're going to be taking a look at what are called systems of linear equations. So in order to go ahead and get a better understanding of that, let's go ahead and see if we can fill in this blank. So it says a solution to a system of linear, and I'm going to go ahead and underline that real quick. A solution to a system of linear equations is where the lines intersect. Okay. The reason why I underline linear is because this is how we find the solutions for linear equations. So through the where the lines intersect. Later on, we're going to be talking about linear inequality. I'm sorry. Yes, systems of linear inequalities, and you'll notice that just like the regular linear inequalities, they have different solution sets. Okay, so it's not just the points that are on the line. So stuff like that. So just to keep it in mind, this is how we find solutions to systems of linear equations, okay? So where the lines intersect. So let's go ahead and kind of get an idea of what that means or how we're going to be graphing these particular linear systems of linear equations. So why don't we go ahead and start with something we already know how to do, which is graph lines. So the cool thing about this is that it's the same thing as graphing lines, okay? So nothing different. We're going to use our skills from before. So let's see. We can tell that this is already in slope-intercept form, right? So I know that my slope here is 1/2. My y-intercept is 0, comma, -3. All right, and that's exactly what the information I had in order to graph this line. Okay, I started off at 0, -3. I know this is my rise over my run, which is up 1. So up 1, right 2. So up 1, right 2. Up 1, right 2, and so on and so forth. Okay, and I can do the exact opposite, which is actually down 1 and left 2. Okay, so nothing you haven't seen before. Perfectly, I don't know where I was going with that, but anyways, so we know how to do this exactly right. So just to confirm, once again, slope-intercept form, slope is -4, or if you want to write it as -4/1, y-intercept 0, comma 6. We can tell from right there. So again, start with 0, comma 6, and we're going to go down 4, and to the right 1, down 4, and to the right 1, and so on and so forth. So no mystery here as to how we graph those lines, okay? Stuff that you've already done before. Now, when we're talking about systems of linear equations now, we're going to look at where. So let's read this up here. It says now put them together and find out where their point of intersection is. Okay. Okay. So now put those two lines together, and we're gonna find their intersection point. And this right here now is a system of equations. I put this equation and this equation all into one system, which means I'm going to go ahead and graph my red line once again and my green line also once again, but they're both now on the same exact coordinate plane. So that's the only difference. Before we would graph them separately on their own graph or on their own coordinate plane. Now they can both be in the same coordinate plane. And as we set up top, we are now looking for their intersection point, where they intersect, and that would happen right about there. And actually, let me use a different color. That would happen right there. So what order pair is that? That is the order pair 2, comma, -2. So 2, comma, -2 is the only solution for this system of equations, of linear equations, because it's the only intersecting point. Okay, the only place where those two lines intersect. Okay, so that's the only difference, guys. Before we had only one linear equation per problem. Now we have, notice we have two linear equations in the same graph. That's the only difference. Now we have them both on the same graph. Okay, so let's go ahead and see what we could do about these practice problems, and I'll have you guys try some out on your own. So right away on this first set of equation, so this is my first system. If you guys notice, there's this little bracket here. This is showing us how many equations are in our system. And in this case, we have 1, 2 equations. And that's what we're going to be dealing with today. 2 equations in our system. Okay? So this first equation has a slope of 1 and a y-intercept of 2. So I'm going to graph my y-intercept first. So I'll just show you guys. This blue one is the first one I'm going to graph. So my slope is 1, so up 1, right 1, up 1, right 1, up 1, right 1, or I could do the exact same thing, but to the left, or rather the exact opposite thing, because I'm going to go down 1 and to the left 1. All right, so I have all my points here. I can make my straight line. Try to use a straight line, guys, especially for systems of linear equations, because if we're graphing and that's the method we're looking to solve, then we need to make sure we identify exactly where the two graphs meet, exactly where they intersect. So let's take a look at the second one. Second one here, I'm going to draw it in red. So I have negative 2x plus 8, so my y-intercept I can see is a positive 8. And my slope is a negative 2 over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and so on and so forth. So I'm going to go ahead and graph my line. Okay, and we know, again, solutions. What are solutions, or how do we identify them? We identify them by the point of intersection. Where do they intersect? At what point? Well, it looks like it happens right here, and that would be 2 comma 4. So 2 comma 4 is my solution. Okay, all right. This next one, we have x equals 7 and y equals negative 2. So again, two linear equations here. I'm going to make this first one in green and the second one in orange, so we can keep them separate so we know which one's which. So let's go ahead and do the green one first. So x equals 7. Well, we know for those types of equations, we can identify them by which axis are they crossing. So if we want an x equals and it has to cross the x-axis, the only types of lines that do that are vertical. So I'm going to make my vertical line here. And I'm actually going to redo that because that was a horrible attempt. Not much better, but you get the idea. That's why I'm saying you guys should use definitely your straight edge, an ID, a ruler, whatever you need. Okay. And this next one is y equals negative 2. So we need a line that crosses the y-axis. Well, that happens with horizontal lines. So I'm going to draw my horizontal line here at y equals negative 2. All right. Now I need my intersection point. It's right there. So my solution is 7 comma negative 2. All right. So hope we're getting the hang of it. Number 3 looks a little harder, which actually, again, not that much harder. The only difference is now we have to rewrite the equation so we can identify our slope and our y-intercept. Let's go ahead and do this one in purple here. So I have x plus y equals negative 2. So I'm actually going to rewrite it. The reason I want to rewrite it is because I want to make sure this is in slope-intercept form so I can identify both my x and y intercept. So let's go ahead and do that. So here, I'm going to subtract my x. So I get y is equal to negative x minus 2. Look at that. That's now in slope-intercept form, so that one's good. Now this one, I'm going to also rewrite. So I'm going to get rid of my 2x here. Whoops. Subtract 2x. So I get negative 3y equals negative 2x minus 9. Divide by negative 3. I get y is equal to 2/3 x plus 3. And this is my second equation. So again, it's still the original two equations. I just rewrote them in a different way. So I'm going to go ahead and draw this line in green. And I'm going to draw this one in red, just so you guys can keep them separate. So I'm going to do the red one first. Start at 0, negative 2. That's my y-intercept. My slope is a negative. Whoa. Sorry about that, guys. My slope is a negative 1, or another way of writing that is a negative 1 over 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and keep going on there. Or we could do the exact opposite, which is left 1, up 1, left 1, up 1, all the way. So again, try your best at drawing a straight line. I'm actually going to continue doing my points so I can make sure I draw a straight line. All right. Now my green one, start at 0, 3. My slope is 2 over 3, so rise 2 to the right 3, rise 2 to the right 3, or I could do the exact opposite. So, sorry, the exact opposite, so down 2, left 3, down 2, left 3, and I know some of you guys already saw the intersection point. So let's connect those dots. And now I can identify where they intersect, and that would be right there. And that solution is negative 3, 1. All right, so all of these looked a little different, but that's totally fine because we were able to graph them all. Once we have both graphs on the same, or sorry, both lines on the same graph, then we can identify their intersection point, which is exactly what we did. Okay, now for this next chart that I have here, and I think I mentioned this towards the beginning of the video, but maybe I didn't. However, I'll mention it again. We might have one solution, no solution, or infinitely many solutions, just like we did before with when we were solving equations. Okay, so we might have the same case here. Now we have to know and identify when that happens or how that happens. Okay, so before I go any further into it, let's go ahead and look at this one solution example and see why we only have one solution. So I noticed right away on my two equations, I don't like the way they look because they're not in slope-intercept form, so I'm going to rewrite them in slope-intercept form. So I'm going to get rid of my x. What do I get? I get negative 3y equals x minus 12. Now I'm going to get rid of that negative 3. So what do I get for my final equation? I get negative 1/3 x plus 4. Okay, that's my first rewritten equation. And I'm going to go ahead and rewrite this one just straight from here. So again, I want my y by itself, so I'm going to add x. So I get 3y equals x plus 6, divide by 3. What do I get? I get y equals 1/3 x plus 2. So I have my two rewritten equations. So I'm going to do this one in, let's see. Let's do this one in green, and let's do this one in red. Okay, so let's go ahead and do our red one first. It doesn't matter which one you graph first, you're still going to get the same intersection point regardless. So let's see. We have a positive 4 for my y-intercept, and my slope is negative 1/3, so down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. Or I could do the exact opposite, which is up 1 to the left 3, up 1 left 3. Okay, I'm going to go ahead and draw a straight line through those points. Let me try that one more time. All right, not so great, but you guys get the idea. At least I have my points here to help me out in case those are the intersection points. Okay, my red one. Oh, did I not use the correct? That's probably why I should redo this. Let's use red. Okay. So one last shot here. Actually, it's kind of better that I did do it in red because I drew a straighter line. All right. So now we have our green one. So I'm going to start at 0, 2. My slope here is now 1/3. So up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. Or the exact opposite, down 1 left 3, down 1 left 3, down 1 left 3. I have my two lines. Now I look for my intersection point, and that happens exactly at 3, 3. Now, how does that tie into my title of this, which is one solution? Well, let me use this. One solution means that you'll have exactly one point. Okay, so if your intersection point is just one point, okay, then you will just have one ordered pair, which means one solution. Okay, so if you ever have something that looks like this, guys, just one ordered pair, then you have a one solution type problem. Now, let's go ahead and look at this next one. Let's go ahead and same as before, guys. Just keep solving them exactly like before. Let's get them in slope intercept form, graph them both, and we'll see our results. So I'm going to rewrite this first one here. I'm going to solve for y so I can have it in slope intercept form. So I'm going to add 2x, add 2x. So I get negative 3y equals 2x plus 9. Divide by negative 3. And so I get y equals negative 2/3 x minus 3. Okay, and actually this one is already in slope intercept form. So let's figure out if we could draw these. So I'm going to make this one in green and this one in red. Okay, so let's go ahead and draw our red one first. So I'm at 0, comma negative 3. Okay, so right here. My slope is negative 2/3. So I'm going to go down 2 to the right 3, down 2 to the right 3, down 2 to the right 3, or again, the exact opposite, which is up 2 and to the left 3, up 2 left 3, up 2 left 3. Let's connect all of our points. Much better. Okay, so that's my first line. Let's go ahead and do the second one. Okay, I'm going to start at 0, 3, and then my slope is also negative 2/3. So I'm going to go down 2 to the right 3, down 2 to the right 3, down 2 to the right 3, or up 2, left 3, up 2, left 3, up 2, left 3. Now, if you guys remember from chapter, I believe it was chapter 3, okay, we can identify a few things. First off, notice that my slopes were the same. And we know that because slopes are the same, then they have to be both parallel. Okay, now we get to the good stuff. Why is this called no solution? Well, parallel lines, what do they have in common? Well, all parallel lines will never touch each other. Okay? Any set of parallel lines will never touch each other. And we said from the very beginning, that only way to identify what our solutions are for linear systems of linear equations is by finding where they intersect. Well, if they're never going to intersect, then how can we have a solution? Well, we don't. That is why this would be no solution. Those parallel lines will never intersect, and so they will never have an ordered pair in common. Okay? So that's how we get no solutions. So, hint, hint, big clue is right here. If you see same slope, that means you have parallel lines. So if you see same slope, or if you're given lines and told to find the solution, you'll know automatically that same slope means parallel lines. If you have parallel lines, it means no solution. Okay? All right. Let's take a look at the next one. Now, hopefully you're putting 2 and 2 together and we're starting to understand how this works. So I'm trying to see if you guys can visualize what the next one will look like. Okay? Now, I'm going to go ahead and pause the video for a second because I want you to get used to rewriting the equations in slope-intercept form and then graphing them both on the coordinate plane. So why don't you guys go ahead and pause the video right now and rewrite this first equation in slope-intercept form and then graph both of them for me, please. All right, let's go ahead and rewrite that. So I'm going to rewrite it over here. 4x plus y equals 3. Well, the only thing I really got to get rid of here is the 4x. And my y is already all by itself. So y equals negative 4x plus 3. So this is my equation. But now look, this equation, which I'm going to do in blue, is the same as this other equation, which I'm going to do in red. Okay? But if they're the exact same thing, then okay, well, let's go ahead and just graph the blue one. 3. My slope is negative 4 over 1, so down 4 over 1, down 4 over 1, or up 4, left 1, and so on and so forth. So if I were to graph that, this is what it would look like. Okay? But this other one is going to look exactly the same, so I can literally trace right over that blue, and I have my 2 lines. But then that's the key, guys. Do I really have 2 lines? No, I have just 1 line, technically. They just both happen to be the exact same one. So then it's just 1 line. So think about it. If you have 2 lines, this blue and this red, and you pile them up on top of each other, okay, they now become the same line. So how many times do both of those touch each other? Okay, well, they touch each other along the entire line, meaning how many solutions do you have, or how many points of intersection do you have? You have an infinite amount of points. So your answer here would have to be infinitely many points or infinitely many solutions. Okay, so hint, hint, if you rewrite your equations for your lines and you get the same line, if you get the same line, then you know you have infinitely many solutions. Okay, all right, let's go ahead and take a look at a problem down here. Now that you have a little bit of experience with no solution, one solution, and infinitely many solutions, and see how you can do. So I'm going to do number 4 with you, and then you guys are going to do number 5 on your own. So right away, I know I want to rewrite these, so I'm going to go ahead and do that just now. So 3x plus 12y equals 4. I want to get the y by itself, so I can write it in slope-intercept. So I get 12y equals negative 3x plus 24. Divide by 12. I get y equals negative 1/4 x plus 2. That is my first equation. I'm going to do that one in green. Let's go ahead and do this other one. X plus 4y equals 16. Whoops, that's not what I want to subtract. I want the y by itself. So I want to get rid of the x. So I'm going to get 4y equals negative x plus 16 divided by 4. Whoops. Divide by 4, divide by 4. I get y equals negative 1/4 x plus 4. So this one I'm going to go ahead and do in red. And now, some of you guys might already be able to tell me what my solutions are. Okay? If you don't know the solutions yet, just by looking at those two equations, let's go ahead and actually graph them. So I'm going to do my red one first. I'm at positive 4, and my slope is negative 1, 4, so down 1, right 4, down 1, right 4, or up 1, left 4, up 1, left 4. So I'm going to graph my line there. Okay. Now I'm going to do my green one here. So I'm at positive 2. Also down 1, right 4, down 1, right 4, or up 1, left 4, up 1, left 4. Although my lines aren't straight, I think you guys can already start to see that both of these are parallel. Another way you guys could have seen, like those few people who actually did figure it out right off the bat, same slope. And what did I write up here? Same slope equals parallel. If it's parallel, then you have no solution. So my answer here is, whoa, that's not what I want. I want no solution. Okay? All right. Up to you guys to do the next one. So go ahead and pause the video and try out number 5 for me, please. Okay, again, let's rewrite them. I'm going to do this first one up here. So x plus 3y is 9. So subtract x, so I get 3y equals negative x plus 9. Divide by 3, I get y equals negative 1/3 x plus 3. This is my first line. All right, so I'm going to do this one in blue. Next one, I have negative 2 minus 3y equals negative 12. I want to get the y by itself, so I'm going to add 2x. So I get negative 3y equals 2x minus 12. Divide everything by negative 3. We get negative 2/3 x plus 4. Okay. So again, if you want to start to gain a little bit of conceptual understanding here, guys, or just to kind of be ahead of the game and get a solid understanding of this, look at your slopes, or just analyze the graphs. Analyze the equations. Okay. If you see something automatically, just like we saw here before on the slopes of these two previous lines, okay, then go ahead and make those assumptions, or not. They're not even assumptions. They're analyzations. You're analyzing the problem and you're coming to conclusions. Okay, so if you see something right away, then go ahead and just go straight to your solutions. But here, notice that nothing's the same. The slopes aren't the same. The y-intercepts aren't the same. So we know we're not going to have something like a no solution or a infinite solution. So let's go ahead and graph this. I'm going to go ahead and graph my purple one first. This one's my purple one, so I'm going to start at positive 4. I'm going to go down 2 to the right 3, down 2 to the right 3, or up to left 3, up to left 3, up to left 3. Finally, just draw a line straight through. Okay, so now let's graph the blue one. I'm going to start at 0, 3. I'm going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, or up 1, left 3, and so on and so forth. Draw my line. I notice these are definitely not parallel, and they're definitely not the exact same line, so I know I'm going to have one solution. Well, what is that solution? Well, it's right here, because this is where they both intersect. Okay? So what is that solution? That's a 2, 3. Okay, great. Now, you guys know me by now. I like to always gain a little bit more of an understanding from you guys. Okay, I want to make sure that you guys really understand what's going on here. Okay, what does it mean to be a solution? Yeah, it means that that's where they intersect. Okay, so what? Well, the reason why it's a solution is because this is, again, an ordered pair. This is your x, this is your y. If you were to substitute both of those numbers into both of these equations, then you should get a solution that is correct or true for both of them. Okay? And just to prove it to you, I'm going to go ahead and do it this way. The first one says x plus 3y equals 9. So this would be 2 plus 3 times 3 equals 9. Okay? Oh. I'm coming across something that shouldn't work. Let me double check my work here, guys. And this is the reason why I do this. I always have to double check my work. So let's see. That's a negative 1/3. Okay. Let's see. Okay. Well, I'm double checking my work right now, and it seems everything is correct. Let me scan it one more time, though. If you guys see an error that I made, please make me aware of it, guys, or just go ahead and fix it on your own. See if you can figure out what happened here. This should be our solution, however. That's my problem. My solution, I wrote it wrong. That's why I always have to check. So hopefully you spotted it. Good job, guys. I didn't spot it right away. The solution is actually 3, 2, not 2, 3. Okay, this makes a lot more sense now. That's why I always like to check my answer. So that's exactly what I'm going to do now. So sorry about that little mishap, guys. But again, this happens. That's the reason why we always check our answers. So back to my original analyzation here. I was saying that if you substitute this x and this y into the original inequality, into the original equations, then you should get true statements. And I'm going to test them both out right now. 3 plus 3 parentheses 2 equals 9. This is 3 plus 6 equals 9, or 9 equals 9. Is that true? Yes, of course it is. Okay, Now let's try the other one. Negative 2 times 3 minus 3 times 2 equals negative 12. Well, this is a negative 6 minus 6 equals 12. So is negative 12 equal to negative 12? Yes, it is. So I know for a fact now that this answer was right. Again, which is great because had I gone off with the solution 2 comma 3 instead, I know I would have ended up something that wasn't true, which actually, as you guys can see from the video, I actually tried that out in the beginning and I was not getting something correct. So I knew I made an error. That's why I want you guys to understand what should be happening when you're getting these solutions, guys, okay? All right. Now, the only other piece of information that I wanted to give you is that, what did we say? We said that if you have an ordered pair, then it's only one solution, meaning that this ordered pair is the only ordered pair that I can substitute back into both of my equations and still get true statements, okay? All right. That's it for my little mini lesson there for you guys. So what I want you guys to do is to try out 6 through 8. So what I'm going to do is I'm going to do 6 with you guys, and I want you guys to try out 7 and 8. All they're asking for 6 through 8 is determine if whether the ordered pair is a solution to each of the systems. Well, what did I just do up here, guys? I tested this solution into my original equations to see if it worked, and I got 2 true statements. So we're going to have to do the same thing down here. So they're telling me that they think the solution is -1, -1. So I'm going to test it on both of my equations. So let's go ahead and do that. If I substitute it into the original one, I get -1 equals -3 times 1 minus 4. This is -1 equals -3 times -1 is a positive 3 minus 4. So I get a -1. Is that true? Yes, it's true. It checks out. Let's try the second equation. I get 2 times -1 minus a -1 equals a -1. So 2 times -1, that's -1. The opposite of a -1 is a positive 1. Whoops, almost messed that up again. So -2 plus a positive 1 equals -1. So what is -2 plus 1? That's just a -1. So do I have a true statement yet again? Yes, I do. Okay, so it's up to you guys now to try out number 7 and number 8. See what you get. Okay, so now some of you guys might have actually rewritten this. You don't even need to rewrite it here. All you're doing is testing to see whether this x and this y will work in both of your equations. So let's substitute them in. Get -4 equals -1 minus 3. So I get -4 equals, well, -1 minus 3 is -4. So that one checked out. What about the next one? So 6 times -1 minus a -4 equals 2. Okay, this is -6. Opposite of a negative is a positive, and -6 plus 4 is a -2. So is -2 equal to -2? Yes, it is. So is this a solution? Yes. -1, -4 is a solution. Okay, good. Last one. I'm going to substitute in my new x and my y into both of these equations. So I get -4 equals -3 times 2 plus 2. Get -6 plus 2. Okay, this one checked out. -4 is equal to -4. All right, let's try out the other one. I get 2 plus 2 times -4 equals 6. I get 2 minus 8 equals positive 6. So this is -6 equals 6. Is that true? No. This is not true. Okay? -6 is not equal to -6. I'm sorry, -6 is not equal to positive 6. So because that's not true, even though this one was true, guys, even though this one right here checked out, it doesn't matter if this one doesn't check out. Okay, they both have to work in order for it to be a solution. So the question was, is 2 comma negative 4 a solution? No. So no, for number 8, 2 comma negative 4 is not a solution. Okay, so hopefully you got the correct answers on both of those, and hopefully now you have a little bit of a better understanding of systems of linear equations. Again, we're going to continue practicing with these in the future sections, but for now I hope you guys got a little bit of an understanding of what it means to be a system of linear equations. Basically the new vocabulary term here, guys, is systems. What is a system? It's a set of equations that can be modeled through graphs on the exact same coordinate plane. Okay, and we find their solutions by looking at their intersection points. Okay, sometimes we have no intersection, which would be no solution. Sometimes we only have one intersection, which is just crossing at one point. And sometimes we have infinite number of intersections, which is when the two lines are the exact same line, so they're basically piled up on top of each other.